Okay, good morning, guys. So obviously we know my voice is still a little gone, but we're gonna do, I'm not here today, so we're gonna do this video lesson just like the normal drill. It's on inverse operations. Then the other two handouts you would have picked up, one is just like a practice sheet for practicing graphing by transformations, finding the equation, and the other one is a progress check of the unit slash the course in its entirety. And then don't forget you have your assignment for this on Monday. Okay, so that will still be collaborative and in groups of 3. This summative will not be collaborative or open book or anything like that. Okay, so inverse operations, essentially what you're doing is finding the inverse. So looking here, it says an inverse is the opposite of an operation. So that's all it is. Okay. So essentially what we're going to do is we're going to swap X and Y. But before we get to any of that, we're just going to do some practice of doing the opposite operations. So what I mean by that is if we have a number, let's say 10, and we add 15 to it, we now get 25, right? Which we know. If we take our final answer, we do the inverse operation and we subtract 15, we get 10 back. Okay, same thing here. So we have 19, we subtract 8, we get 11. We do the inverse operation, we add 8, and we get 19 back. Okay, so on and so forth. So I will do these. So you have 50. When you take 25 and multiply by 2, we're going to do the opposite. Divide by 2, and you get 25 back. You take 40, you divide by 5, you're going to get 8. We're going to do the opposite operation. We're going to take 8, multiply by 5, and you're going to get 40 back. You take 12, you square it, you're going to get 144. You take 144, you square root it. Square root is the opposite operation of a square. And you're going to get 12 back. You take 100 and square root that, you're going to get 10. You take 10 and you square it, you're going to get 100 back. You take 30, you do the sine of 30, and you're going to get 1 over 2. We do the opposite operation, which is sine inverse. You do sine inverse of 1 over 2, and you're going to get 30. Remember, this 30 is in the value of degrees. Okay? So you can pause it here if you need a second to fill that out. So that is the essence of the inverse operation. Just like when you're solving for X, if you had a very simple algebraic equation, let's say you have 3x minus 4 equals 0. And I said, okay, you need to solve for X. You do the inverse operation. So you do 3x equals 4. You add 4 to both sides. Then, I shouldn't have written it here. Then you have a multiplication here. So you're going to divide by 3 on both sides, and you're going to get x equals 4 over 3. Okay, same idea of what you've always done when you're solving for a variable. You do the inverse operation. The opposite operation is the same thing as saying that. Okay, so we go here now. Sorry, I have all my pens on the table. Okay, there's a little comic at the bottom that you can read on your own. So it says state the operations required to do the inverse of each of the following in order. So here you have the number 10 is like your X value. Okay, they're saying. Then you have, it's saying we're going to multiply that by 2 and then subtract 4. So we're going to take 10, multiply it by 2, and then subtract 4. In that order, we're following the same order that they are. Okay? And we are going to get 16 when we do that. Now we're going to do the inverse operation. To do the inverse operation, we are going to first, you do it in the order backwards. So we're going to add 4 and then divide by 2. So add 4, divide by 2. We're essentially working backwards. So we're going to say, okay, it was minus 4 was the last thing done, so I add 4. Times 2 was the next thing done, so I'm going to divide by 2. Okay? When I do that, I'm going to get 10 back. Okay? Here I have a 12. Sorry, my bracelet keeps hitting the table. Here I have a 12. I'm going to add 8, multiply by 3, and then add 1. So 12 times 8. Oh, sorry, I messed up. 1 second. You're adding 8, not timesing by 8. So we add 8. So 12 plus 8 times 3 plus 1. Okay. Now, because you're adding first, this should go in brackets to say, let's do this first. So you have 12 plus 8. That's a little hard for you to see because of the whiteout. And that's in brackets. Then you have times 3 plus 1. This is going to give you an answer of 61. We do the inverse operations in the opposite order because we're going backwards. We do everything opposite. We're going to subtract 1, divide by 3, subtract 8. Okay, so you would do 61 minus 1 divided by 3 and then subtract your 8. You do that and you're going to get 12 back. Here you have 7. You add 2, square root it, and then divide by 3. So it's saying, okay, sorry, I just coughed in all of your ears. Okay, so you have 7, you add 2, so it's saying do 7 plus 2, but then it's saying square root that. So then we square root that, and then we divide this whole thing by 3. Okay, so you're doing this first and then this. That will give you an answer of 1. 7 plus 2 is 9. Square root it, you get 3. Divided by 3 is just 1. Okay, to do the inverse operation, you're going to take 1, you're going to multiply it by 3, and then you're going to square it, and then you're going to subtract 2. And then this will give you your 7 back. Okay, so that is kind of like the essence of, again, doing the opposite operation. That is super important to understand that we work backwards when we're doing that, just like solving for a variable. Okay, so we're going to flip this over. We're now going to deal with inverse functions. So it's a bit more than just inverse operations. Okay, so the inverse of a function, the way you write it, kind of like how for trig it's sine and then we read it as sine inverse. The inverse of a function is kind of like f of x, but the inverse. It's like that. Okay? Now, when you have an inverse function, sometimes there are points that are unaltered, like certain points on a graph that don't change when this transformation happens. And those points are special. They're called invariant points. Invariant points. Okay? So we're going to ignore these two graphs for a second. We're just looking at these graphs here. And it says, complete the following table. I said we're going to look at these graphs. We're just going to look at these tables, sorry. So it says complete the following table. So that is what we're going to do. So it says, here's a number. You have a number 4. And then it says, okay, evaluate the function at the value of 4. Okay. And our answer is 7. So now we're going to look at these graphs. We're going to use this table, look at the graphs. So we're saying, okay, the function at a value of 4. So we go to x equals 4. And at 4, the graph is equivalent to a value of 7. Okay. Then if I do, okay, well, what is the function? What is the inverse function? So what if I swap x and y? That's my x, that's my y. Okay. What if I swap them? What if I say I want the inverse of the function at 7? I know that my answer is going to be 4 when I swap x and y. Okay. I can confirm that because this is the graph of the inverse function. So this is the original, this is the inverse. And if I do the function at a value of 7, I am at a value of 4 right here. Okay. So the same thing will apply. So if you look at the function, the original function at a value of 8, you get 11. If you look at the inverse function at a value of 11, you are going to get 8. And feel free to pause the video and just confirm those. Here, if you do the function at -6, you look at this graph for -6, you're going to get a y value of 0. You look at this graph and you find the inverse function at a value of 0 for x is going to give you a y value of -6. So your x's and your y's just flip. You look at your original f of x, when x equals -9, you're going to get -6. When x equals -6 in the inverse, you're going to get -9. Okay, so now we're going to create a table of values of the key points for each of these functions. So when we look at the original, like I said, we use the endpoints and the corners. So you're going to get -10, -8, -3, 6, 4, 7, and 10, 13. And then for the inverse, same thing. You still use the endpoints and any corners. And you get -8, -10, 6, -3, 7, 4, and 13, 10. You'll notice all that happened is your x's and your y's flip. This was 10, 13. It's now 13, 10. 4, 7, 7, 4. That's all that's happening. Okay. So now it's more of an investigation at the bottom of the sheet here. It says, what do you notice about the numbers in the tables from part B? So here you can just fill in and say, well, the x values and the y values are switched. Okay. So that's what we recognize ends up happening. Now we're going to look at a brand new question. This is the graph. This is the original graph that they've given us. We need to graph the inverse of the following function. We don't use a transformation table for this. We're literally just going to use this as our OG table of values using our endpoints and the corners. And then for this graph, we're just going to flip all of our x and y's over. Okay, so here we have OG points right there, endpoints and corners. You're going to get for y equals f of x, -4, 3, -2, -3, 1, -2, 2, -4, and 5, -2. Okay, now we have to graph the inverse. So we're going to label And we're just going to flip our x and y's. So instead of negative 4, 3, we get 3, negative 4. Negative 3, negative 2. Negative 2, 1, negative 4, 2, and negative 2, 5. Okay, so now plotting these points, we go 3, negative 4, 1, 2, 3, 4. Okay, you get, what color did I use? I used a green, but that's okay. And then you're going to get negative 3, negative 2. So those two will connect. I should have brought a ruler. Okay, and just like that, I have a ruler. I personally think it's easier if you connect the dots as you go along so you don't get overwhelmed and connect the wrong dots. So that's your first one. Your next one is negative 2, 1. Should connect here. Then you have negative 4, positive 2. Just here. And you have negative 2, positive 5. Right here. Okay, so not much you can really tell, but you can tell it has the same kind of weird W shape. One of the sides is longer than the other one. Now what I'm going to show you is, if you didn't notice, now I also will label these. So this one is your regular y equals f of x. And the pink here we have is y equals f inverse of x. The graph that you end up getting from doing the inverse is actually a reflection along this line here. So if you put a mirror right here, oh, that was inaccurate. If you put a mirror right here, you end up getting this reflection, okay? So I'm gonna get you to make a little note at the bottom of your page here and just write the inverse function and the original function are reflections along the line y equals x. So in grade 9, the most basic line that you learned ever was just y equals x. That is the equation of a line. Okay? So we've done reflections along the x-axis, the y-axis, but inverse functions are actually end up being a reflection along the line y equals x. Okay? So moving on. It says here, for the function shown, state the domain and range of the function. Okay? So let me get sorted here. Okay, so simply stating the domain and range of the function. You do your equivalent of what you would say d equals, but it's not actually an equal sign. So we have domain and a colon. Same thing, x belongs to the real set of numbers such that, and we look at our domain and say, okay, what are the restrictions on x left and right? So the lowest we'll ever hit is negative 1, 2, 3, 4, 5. The highest we'll ever hit is positive 1, 2, 3, 4, 5. So negative 5. So x has to be greater than or equal to negative 5, less than or equal to 5. Done. For your range, y belongs to the real set of numbers such that we look at our range, our vertical axis here for y, and we say, okay, what's the lowest y will ever be? This is the lowest here, so negative 1, 2, 3, 4. And the highest will ever be is 1, 2, 3. So we say y has to be greater than or equal to negative 4, less than or equal to 3. And that's your range. So now it wants us on this same graph to graph the inverse of the function. So we now are in charge of making our little table of values. So you have here one table and another table. I didn't leave much room, but I am going to label these as y equals f of x and y equals f inverse. Okay. Now here I have to write my points. So for my original points, again, I use my endpoints and any corners like that. And I have negative 5, 4, or sorry, negative 5, negative 4, negative 2, 3, 0, negative 1, 3, negative 2, and 5, 2. Okay. And these are, of course, for your x and y. And then for your inverse, again, for x and y, we just swap them. So instead of negative 5, 4, we have negative 4, negative 5, 3, negative 2, negative 1, 0, negative 2, 3, and 2, 5. So we just swap those. But now these are the points we have to graph. So we go negative 4, negative 5, 3, negative 2, 1, 2, 3, negative 2. So that ends up being on top of one of our points already. Now, personally, I would connect these now before we get lost in all those dots that are going to appear. Then you have negative 1, 0. So negative 1, 0 right here. So that's another line. Then you have negative 2, 3. So that also hits another one of your previous original dots. Those would be your invariants. So this one and this one are like invariant dots or invariant points. Then you have 2, 5. Okay. So it says here, is the inverse also a function? So we know that the first one, the original, is a function because it passes the vertical line test everywhere. You can see from the graph that I have in turquoise here, it very much is hitting like 3, 4 different points here. So it is not a function. It does not pass the vertical line test. So no, the inverse is not a function. It fails the vertical line test. Okay, now we are going to state the domain and range of the inverse. So we do domain equals exponents of real sets such that, and the lowest point that I hit for x is negative 4. And the highest point that I'll ever hit is positive 3. So I say x has to be greater than or equal to negative 4, less than or equal to 3. And for your range, I look and I say, okay, the lowest point I'll ever hit is -5, highest point is 5. And what you'll notice, that what they're asking in part E here, is what do you notice about the domain and range of the function compared to that of the inverse? So our original domain of the original function compared to the inverse function's domains. So the domain and range, they essentially switch. Here the domain was -5 to 5, and the range was -4 to 3. Now our domain is -4 to 3, and our range is -5 to 5. So the domain and range switch. Which makes sense because your x's and your y's are literally just swapping each other. Okay. I'd say here is of the whole lesson, probably the trickiest, which says a lot because it's honestly not that bad. You're essentially now just actually swapping your x and y. So you have here f of x equals 4x minus 3. Now, I've always told you f of x is just another way of writing like y equals 4x minus 3. This is still a linear equation. So we're going to just do that. Rewrite this as y equals 4x minus 3. Now that I have that, I'm actually going to do the inverse now. I'm going to swap my x's and my y's. So those are going to swap. So I have x equals 4y minus 3. And now my goal is to isolate y so that my equation is still in the form of y equals blah, blah, blah. But now that I've switched my x and y, it will actually be the inverse. It would be as if I was solving for x, but because I've swapped them, because the proper way to write an equation in math is by saying y equals, that's why I swapped them. So this is where our inverse operations come into play. And I have x plus 3, and 3 comes over, equals 4y. Then I have to isolate y, so I want to divide both sides by 4. So I'm going to get x plus 3 over 4 equals y. So then, in conclusion, you would say, therefore, f inverse equals x plus 3 over 4. You convert your y back to the function notation. Okay? For the last one, we're going to do the same thing. We're going to write it with a y, and we get y equals x plus 2 squared plus 3. We're going to do a little swap. And I'm going to write x equals y plus 2 squared plus 3. And then here, my goal is to isolate for y. Now, this one's a little trickier. The first thing I can easily get rid of is this plus 3 by subtracting 3. So I'm going to get x minus 3 equals y plus 2 squared. Now, I need to get to y, but y is trapped in brackets with a power of 2. The opposite operation of a square is a square root. So I do the square root of technically both sides. So I get root x minus 3 equals. I do the square root of this side, it cancels out the square, and I'm just going to get y plus 2 on this side. Okay? Now, something you need to remember, when we have the square root, it is the plus and the minus of it. Okay? So remember, just because like 4, for example, the square root of 4 could equal plus or minus 2. Positive 2 squared is going to give you 4. Negative 2 squared is also going to give you positive 4. So it is the plus and minus. Now we have one more step to get our y completely isolated. We have a plus 2 that needs to come over as a minus 2. So you can bring it over as minus 2 and then plus or minus this, or you can have minus 2 on the outside. It's totally up to you. So you can do minus 2 plus or minus square root of x minus 3 equals y. Or if you prefer to write it as plus or minus the square root of x minus 3 minus 2 equals y. Totally up to you, okay? Generally, people don't like the plus or minus just starting off an equation, so they tend to prefer this one. Okay, so then you would write therefore f inverse equals -2 plus or minus the square root of x minus 3. Okay, so that's the whole lesson. That's the only new thing for today. Your other handout that was second that is printed for you there is your practice for graphing and for finding the equation, which is what we did over the course of the last 3 days. And then also you have the progress check there, okay? So there's no test for this unit, no quiz. You just have the assignment on Monday. Make sure everyone is here. On Tuesday, we have our review for our summative that we'll be writing on Wednesday. It is not open book. It is like a test, okay? It is not collaborative. Then on Thursday, we have review for the summative that you will write on Friday. So you're actually writing the summative on Wednesday and Friday, and then Tuesday and Thursday are review for those days, okay? Have a great weekend. I will see you all on Monday.